Hello and welcome back to Introduction to Number Theory. In the previous video, we studied a sequence, a geometric sequence, generated by a non-zero remainder modulo p, which we denoted by a. And we realized that within this sequence, there exist exactly k pairwise distinct remainders, where k is equal to the order of a modulo p. And these k remainders repeat cyclic over and over again. In current video, I would like to study the order of a remainder, which is the power of a. So we know that order of a is equal to k modulo p, of course, which means that k is the least positive integer power, such that a to the power of k is equal to 1 modulo p. And what about the order of a to the power of m modulo p? Well, denote this order by L. So L is a positive integer, and a to the power of m and to the power of L is congruent to 1 modulo p. But a to the power of m and to the power of L, we understand that this is equal to a to the power ml. So once again, we go back to this sequence, and we now need to find out where are remainders equal to 1 in this sequence. Well, here it is, and here, and here, and so on. So we understand that only those powers of a which are divisible by k are congruent to 1 modulo p. Therefore, ml must be divisible by k. What can we do with that? Well, since we are looking for L, this is what we need to find, and m and k are given, let's divide this divisibility by the greatest common divisor of m and k. This will lead us to another property of being divisible, another divisibility, m divided by the greatest common divisor of m and k multiplied by L should be divisible by k over the same greatest common divisor. Why did we do that? Well, the answer is simple. Now these two multipliers, these two factors, these two numbers are mutually prime. So since L multiplied by something mutually prime with this guy here should be divisible by this guy here, from this it follows that L itself should be divisible by k over greatest common divisor of m and k. Okay, so now we have some information about L, but, well, this conclusion is actually equivalent to the previous condition. And this is, of course, equivalent to the previous condition. And this is, of course, equivalent to the main condition. So we understand that all powers L such that a to the power of m to the power of l is congruent to 1, all such l are divisible by k over GCD of mk, and for any l such that this holds going up, this also holds. So what is the minimal value of L? Well, the answer is obvious. So finally, L is equal to the k over the greatest common divisor of m and k. Let me just write this answer over here. So this is what we finally got. It is equal to k over the greatest common divisor of m and k. And this is what we wanted to find.